Hello and welcome back. My name is Corey and you're my rubber ducks for the evening. And this is the series series of episodes, I should say, where we are creating a programming language from scratch. The programming language is called Tang. Stands for template language. That is, the goal of this language is to be able to write templates that produce, when executed by Tang, that they produce HTML output. That's the goal. And of course, this is written using C++, modernish C++, and using a few tools such as Flex and Bison, and most recently implementing ICU for our Unicode support. And as I've said before, if we don't write it, it doesn't exist in the language. So that's been our goal. What we want to do is sorry, my brain just kind of stopped working. It's rebooting at the moment. That's my shortcut. Forgot what my shortcut was to get to the screen. Well, have been working on getting slicing working in our program. And in the last episode, we got slicing along with negative indexes, whichever you prefer. We got it working for arrays. And now the point of this episode is to extend that functionality to strings. And maybe do some, if we have time, maybe do some cleanup of having to list all those different classes for the friend classes in the computed expression. What is it? Computed expression integer has like string and float and array and stuff like that. Yeah, we want to get away from that. But if we have time today, we'll do that. But first, I normally say nothing up my sleeves. I haven't prepared anything here. And if I say git log, the last commit you see was episode 48. And that is, that's the end of the last episode. And if I say git status, there's no code changes. So we are working all completely from scratch. Everything in front of you, 100% live coding, meaning you see all my mistakes and everything. So we're just going to jump in, and I think the easiest thing for us to do is let's open the test document. We're going to open we know we're working with strings, and this is going to be a computed expression string. So we're going to need the include for computed expression string, the source for computed expression string, and I'm also going to open the include for computed expression array so that we can reference it, and the source for computed expression array. I think that's good for getting us started. And if we look up the word slice, we'll see, there we go, had array slicing, and we had all of this code that we wrote. I'm looking for index, string index. I kind of want to do string slice. And in order to do that, there we go. We're just going to add on here. So this is going to be, instead of string index, it will be string slice. And what's the first thing that we're going to do? Can I say ZC to close that? Where is slicing? Array slice. There we go. And we just started off with, a slice with all default values. I think I like that. So let's just gonna say let's let's start it there. So a slice with all default values. And in fact, you know what? It may be easier to just, if I were to start here and say, so this is 763 and percent should take me to the end, 900. That's how many lines that is, 763 to 900. And so how many is that? 137. Well, from where I am right now, 136. So yank 136, and yeah. Now, what's my string need to look like? I think I need, what if I just pull this? There we go. And so this gives me the $sign, a multi-byte string, and a period. I think I can deal with that. And what if I just call print directly on this? And here I say : closed. All right. So what is the point of this? Well, for the next one, I can say, oh, well, that should be a -1 and have the same type of test, but I'm just running it as a single single thing. Okay, so I think we'll go with that, and right now I'm just copying values. So there we go. And this, I think, should be backwards. That should be a $sign, and then we should go, that should be a period. All right, I'm just gonna start here. And default, so this is going to be default values, and just say should be, no. Okay. On the right hand side, make clean, and now make test watch, and that's going to get started compiling. And I'm expecting this to fail. Why? Because we have not written the slice method for strings. And once we write it, the first two should pass, and then the remaining ones should fail, and we will fix them up in turn. For the moment, oh, 760. Had one extra closing parentheses, or brace, excuse me. That's the word. Okay. And we are indeed failing the first two tests. That's what we wanted. Never thought we'd be so happy to fail a test, right? Now, we know that the array, we need this slice thing here, so I'm just going to copy that We'll put it after index. And what does the slice look like? Oh, this is going to be ugly, right? Because it's big. There's a lot going on. It starts off on line 65 and it goes down to line a lot more than that. 137. So that's going to be, what, 62 lines? So if I just yank 63 and go here, so after the index, there we go. And I'm just going to go down to the bottom. There we go. Was missing the closing one. Okay, so I can't do math evidently. Or I did it from the wrong place. Either one could work. And now this is a string. Now it's going to not like anything because we've got no, let's just write this and then it's going to complain. So this arrow contents dot size. Why? Because contents doesn't exist. So it's line 77. There we go. And it needs to be this, is it source? Length, source.length. All right, next one. Source.length. Okay. This is source dot substr I comma 1. So we're grabbing one character at a time. Okay. And I don't think I got everything. But let's go ahead and do this. This is going to be string, and instead of new contents, it's going to be a string about new string. And we're just going to say, instead of this, we'll just say new string plus equals this arrow source substring. Okay. Return computed expression string, new string. And I'm going to take a peek here at 5. Yeah, I've got skip as negative, but I stopped there. So evidently I didn't do my math correctly. So I'm going to yank 8 and then go back to buffer 3. There we go. Skip is negative. And think it's going to cause some trouble here. And watch it not be called source. That's what I get for not looking ahead. Val, of course. Okay. So stuff is still failing. I guess that's good, right? No. Well, I mean, it's compiling. How about that? So let's go back. The first one is 6:30. So it is our first test. And this one should just be a copy. And $, followed by a period. So yeah, it should be a copy. Let's see. First, let's see, are we getting into the slice? So to do that, we'll just say cout here. Should see here twice. We are not. So I have a question. In Bison, expression, what counts as an expression? test, but keep going, close. There's a lot of expressions all over the place. Open statements, close. So slice is, of course, made up of using an expression, but yeah, it can be a string. Okay, so that should be just fine. Let's go back to our test, and I want to see the cout of p1.dump bytecode. And it should be as simple as null val 0 That doesn't make any sense. Why is the string... Do you know why? I think I know why. The string is not showing up because we have a bug. And, oops, wrong window. We can fix this. B2, is that right? B3. And... Oh no, this is the string, sorry. This is not where the bug is, or what I'm thinking the bug is. Do I have? No, I don't. I want to go into the source for the AST node for our slice, and I think that we're not processing. There we go. So we've got our dump, our compile pre-process, and look what we're missing. We don't have it for collection, which means we weren't pulling in the string, and so it wasn't doing anything. There we go. Now the string is showing up right there. Oh, and look, we're passing our tests. But the point is okay, the string wasn't showing up. So that was missing. Before I go any further, that's a bug we just fixed. So git diff for source AST node slice, and it is that one line, and we're going to add that. Where is it? Source AST node slice, and git commit with a message of bug fix AST node slice was not processing expression during compile pre-process. All right, that should be, there we go. Let's go back to our, okay, we got that fixed. And we can see our bytecode is working there. And of course, if we put it on the second one, we'll get an integer 1 that is made negative. Slice, print, and it's evidently correct because it's matching what we told it that we were expecting. All right, let's continue. So now slicing with a positive value. Here's where it gets more difficult. We know that at this point, okay, we'll create a copy of the string. This is, we'll reverse the string, keeping multi code points in the correct order. All right, so we know that that's happening at this point. Now, if we slice with a positive value, the problem is now we've got, do we really want to keep messing with all of the code points, or do we want to just make it easy to read? I think we would rather make it easy to read, in which case let's call this A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. There. We're doing that. Close it, and we're going to call : 1. And this one should compile correctly now. And if we can remove the Z at the end just to make sure that it is in fact doing it, and it is. Now we're going to do it starting with a skip of 2. Okay, so we've got a skip of 2, and what's this going to look like? It should be A, and we're just removing every other one. That's what it should be. And then this one is 1, 2. And I'm just going to put the one that's going to fail here. I'm expecting the one for line 660 to fail. Yeah, but notice it does start on B, and it's exactly what we would think it's supposed to be. So yeah, now it should pass. All right. There we go. Now, I have a 1 and let's say 13. No. A 1 and a we can do more than that. How about 17? 2. And it's not going to be all of these, but that should be fine. Oh, because I've got more than one print in there. There we go. And it should stop at P. Should pass now. Okay, now we have to do, I don't know if the alphabet is backwards. Aren't there some people who memorize it in case they get pulled over? -1. Okay, Z, Y, X, W, V, U, T, S, R, Q, P, O, N, M, L, K, J, I, H, G, F, E, D, C, B, A. Let's just see if that passes. Line 674. It passes. Okay, good. And now we're going to do it with a -2. And this is going to fail, but yeah, ZX. Okay, just making sure. And might as well grab it again and -2 colon -2. Gonna fail, that's okay. There we go. It should start with y, which is what we would expect. There we go. Everything's passing. Now, a slice with a negative value and a non-default begin and end. Okay. And let's do, grab the entire alphabet backwards. What did I have? -1, negative, about 17, -2. I'm not going to pass, but there we go. Now it should pass. And we've passed. Okay, how many more of these do we have? I still have quite a few. Okay, this is still going to be, we've got -300 to 301. Actually, let's just do it that way. And we should get the entire alphabet. I've got that somewhere. There we go. That should pass. Does. So now it's going to be now the opposite direction, and we should get nothing. That is, it should be empty, because we're going to have 300 to -300. We're good there. -1, and this should be the reverse alphabet. There's a reverse alphabet. That should be passing now. And again, if if you're a purist and say, no, I want to see it fail first, just delete something and you'll see that, yeah, it failed. And, okay. We're going to do this again. This time, we've got a -300, 300 -1, and that should be empty. Good. This time with a zero. Both of those should pass. All right. And then a double slice. Ooh, we haven't done one of these yet. So we've got a colon, colon, 2 followed by -3 colon colon -1. So it's going to be end up reversed. So let's grab a reversed alphabet. There we go. It's going to fail. That's right, but it should start with the U. That's right. And go all the way to the A, every other letter. All right. It's running. Now, you notice our milliseconds are creeping up there. I think we're going to tackle that next. That is, there's something we can do to improve our time. But for right now, we have, I'm on the wrong window. We've got a whole bunch of tests now. We've got strings working. We know that it works for multi-byte. And at least if it's a multi-byte grapheme that that ICU recognizes. And then we just did all the other stuff that's just really quickly testing things with the alphabet. That's good. What's our get diff? We added a slice. We're going to say add dunder slice to, you know, it's just probably easier to say computed expression string dunder slice and associated tests. 200 lines. Okay. Most of that was testing. Now, what can we do? Because at this point we're clean. I'm going to go back and let's see, the computed expression string. Yep. And the problem is on the dunder slice. And we're right here, dunder slice. What I want you to see is the length on that line. The length on this line. Again there. And actually just over and over again. So there. There. Yeah, there. Here. Oh yeah, there again. What is the point of me bringing this up? Oh, then it went back up, scrolled up to index. Every time that we call length, we have to calculate the graphemes. And so that could be multiple times just for a single slice. That's bad. So what can we do? Well, I've never used this feature before. What I'm about to suggest, that is, and that is to use a mutable object or a mutable value on the object. Why do we need that? Well, okay, so if we look up for the computed let's go to the source. excuse me, we're going to edit the include for our, Unicode string. Because ultimately, this is our interface for ICU, right? And at the bottom, there's just the private string that is the source. And that's it. And then if we edit the source Unicode string, we'll see that get grapheme offsets occurs there in the substring. The substring has to perform it. There. The substring has to perform it, as well as the length has to perform it. And so, what would be nice is if we had a way of caching it. But what did I say performed it? Length, which is const, and substring. Where is substring? There it is, which is also const. And normally, if something's const, you can't. You're not supposed to be able to modify it, but we need to be able to change. We want to be able to catch it. It's like we don't want to calculate this if we don't have to, but if we do calculate it, don't throw away the results. Keep it. And that's what the mutable is for. So we're going to add a cache of the what's the word I want to say? Sorry, my brain just stopped working. Grapheme offsets, if they happen to be calculated. And what do I want this to be? I think I want this to be we could have it as a shared pointer. We could have it just as an maybe optional. That should be std. Optional. And what is it? It is a standard vector. A vector of. What is graphemes? Size t. Okay. And we'll just call this offsets, grapheme offsets. Let's use that. Why did I put a period there? Have no idea. Okay, so it's optional, which means it doesn't necessarily exist yet. What do we need to add to the stuff here? Pound include, is it optional? And pound include vector. UnicodeString.o recompiled. We should be fine. And so why did this happen? Because somewhere. Oh wait. Well. Still, it would let me see what compiled and Unicode, and then the Tang test, and then the Tang shared. Tang test, garbage collected. But I bet string, the make file for our, because what uses this? The computed expression string, and I bet that this is not listed as a dependency of it. So we're going to add that. So it needs to be include include slash UnicodeString.hpp. There we go. So now we can, so we've got grapheme offsets. And so get grapheme offsets is still a static function, so it's a function that's only available within this program, excuse me, within this file. It's not exposed to the outside world. That's the goal there. And now the substr. So instead of offsets, I am going to from 43 down. Sure. Let's see if this works. So %s from 43 down, what I want to do is I want to change offsets and a period to this arrow grapheme offsets arrow. Okay. But let's redo this now. And what did I say? I wanted it from 44 to the end. And how far is the end? 90. So 44 to 90. Let's go back to the beginning and redo that, but to say that it's only for 44 to 90. There. We're going to try this again, and do I need to escape that with a period? All right, let's work on this. So to compute the grapheme offsets. Now, do we need to do this? It should just be if not this arrow grapheme offsets. If that's the truth, then this arrow grapheme offsets is equal to that should work. We should probably do the same thing here. But okay, this is kind of like the first step. We probably need to do the same thing with the offsets. Let's figure out what this is now. Go to the first thing. No match for operator equal. Optional and okay. So that should probably be an asterisk and an asterisk. See, Corey, we're doing it twice. Is that a problem? Yeah. We'll get there. Passing a const vector long unsigned int as a this argument disqualifies. Oh, because I haven't set it up as mutable. Okay, and now go back line 65 and because it should be this arrow grapheme offsets. So in this one line, can I do offsets to this arrow grapheme offsets? And it's not going to like that. So, I mean, minus this grapheme offsets dot at position oh. On all the others, I didn't do a period. I did arrow at. Segmentation fault. Okay, that's always fun. Start from a brand new one. Will probably still happen, which since it's segmentation fault, that means it's going to be, should be, a pointer issue. If it's still happening here. If it goes away, then it's because, again, something didn't get recompiled that should have. But if it does go away, then, well, that will. It went away. So it was just getting everything recompiled. Now, I don't like the fact that we're having to basically do the if not this graph frame offsets. So what I want to do is I want to create another a private method that is cacheable values for the object. And this is going to be a void, and it's going to be generate cached values. It will be const, but just like we've got this here, oh, the problem is I was trying to hide the Unicode string, the ICU string behind this, and yeah, I'm going to have to be shared pointer cache of the ICU Unicode string. And this is going to be a mutable standard shared pointer, but can I do this to avoid? I don't think I can. Use string. I mean, that's what I want to do. Question is I need shared pointer. Instead of optional, let's do memory for the shared pointer. I'm expecting some other problems. Segmentation fault, that's good. Say, Corey, why is it good? Because I'm not done yet. But it got past that. It was... Are we able to do it this way? So use string. Okay. And then generate cached values. That's what I So I'm going to have this function at the bottom. Generate cached values. And I mean, you can see that what I'm trying to do, I want the length to just call generate cache values, which will generate that. And then we need it again up here. But the use string, if not this use string, then I want to say this use string is equal to what's the right way of writing this out? All right, so ultimately this is what I want to do on this line, on the to generate the offsets. It's using the stored use string. However, problem is up here, how do I set the use string? Because it is a shared pointer to type void. I don't need std there. Make shared ensue Unicode string, and now it should give me the error that no match. Didn't expect that. So now it's just not liking why? Because this is going to be a or static cast PTR, is that right? Yeah. I don't remember what it's called. I've used it before, but... Or is it static pointer cast? Static pointer cast. Oh, pointer. Pointer. It still won't like it. I know that, but hopefully we're closer than we were. There we go. At least I hope. Okay, segmentation fault. Again, I can deal with this. At least I hope. Okay, so make clean. Make test-watch. So while we're doing it, let me explain at least what my thought process was on the left-hand side. So the goal is to hide whatever UString is. So I can make a shared and say it's a Unicode string, and I just realized that, well, this I can pass in the Unicode string from UTF-8, which is returning something. It's an R value, but Unicode string probably has an R value. That is, it's a roll of 5. It's a move assignment operator. That should be fine. It should allow the shared pointer to accept control of that. And then when we need to use it, we have to do it. We have to say, okay, this UString, do a static pointer cast to the type of pointer that it is. We still have a segmentation fault, though. Now, we don't know if that's because... Actually, we're not using grapheme offsets. Excuse me, we're not using UString. So here's what I'm going to do. I'm going to look for UString. I don't think it's going to like this, but that's okay. Temp substring. And normally I don't like... was that the only place? Oh, okay, so it's this is the only place. Okay, so I can say a static pointer cast to an ICU Unicode string this or UString probably not going to do away with our segmentation fault, but okay, we have something to work with. So I just want to make sure that I've got a clean compile, and then we'll GDB it and just find out where the problem is. Then again, it may just be that because I'm trying to play fast and loose with these memory structures, trying to hide whatever class. Okay, so we're going to say GDB build apps test UnicodeString. Okay, and let's just say run. Okay, a backtrace. Let's see. Where are we getting it? So this is null. That's bad. This is null. This is null. Generate cached values. Line 95. Which one is this? Okay. So when calling the substring, we get in here and we need to, yeah, so I mean we can go from the other end. We're running the tests, and there's a test body, so it's the test line number 19, whatever, it doesn't matter. And then we get into the we call the Unicode substring, and whatever the substring calls generate cached values, and that, so at line number 95, then we get into vector, and it's the equal, and the this is empty. You know what? I think we have to solve it the exact same way that we did the other one. Yes, we're going to quit. And that is, we have to say this grapheme offsets is equal to a make shared. And what is this? This is a vector of size t. And we're passing in that. So we're adopting it. That's my theory. We're going to hope it works. Success! Yay! And we're still at 4 milliseconds. We also still have all the debugging stuff in there. Excuse me, I mean zero optimizations and all that. But the main thing is that we should not be having to generate our cache values over and over. So what I'm going to do is I'm going to check out, what I'm curious of is okay, so I've got count and cached, and I'm going to no, count plus plus, and then cached plus plus, and now just say cout count cached and line. Oh. These are ints. See how that's not declared? How dare it not be declared? We'll do away with that in a moment. What I want to see is I want to make sure that there's a difference between count and cached. Oh, yeah. That's a big difference. So, in theory, what we're seeing here is we're seeing the fact that this should be a completely different run. That's the execution of one string, meaning its length, or to calculate the graphemes or whatever. And so I'm only having to run it once. So I only had to calculate the grapheme offsets once versus counting this 357 times, or 369, yeah. So before we were doing that much work, now we're doing that much work. All right. So, what did we get out of this? We got, it's 5 milliseconds total. It's, and if I run it again, five milliseconds. So I'm at the upper end. And now the question is am I... What I was going to say is, the quick question is am I... I'm wondering if... It always scares me to use shared pointers because they can be so slow. I'll worry about that for another time. For now, though, this is good. Let's commit it. In our... Oh, we need to remove that from UnicodeString.cpp. That is that. And I want to say make clean, and now recompile it while we're doing this. First of all, for the make file, what did we do? We add as for string. That's fine. And now This last one is that we add caching of graphemes. Of to UnicodeString processing. Okay. And now, the last thing I think I want to try is in the make file. I'm just curious. If right now, you see we've got OG, and if instead we do three, what's going to happen it's going to take a little longer to compile, but I just kind of want to see where we are. Yeah, that's what I figured would happen. Our time would really drop down. And even though that's saying 43 tests, there's a lot more work than that. 2 milliseconds, and we might be able to shave that down again just by rethinking how we handle some of this stuff. But for right now, I think we're okay. I'm going to undo that change. Oops. There we go. And from this point, let's, are there any changes to our documentation? There is a little bit, not a lot. Oh, I'm wrong. There's a lot. That's fine. Docs for episode. Who knows what episode we're on? I don't know anymore. Episode 49. We're almost at episode 50. Never thought I'd still be going on this, but that's all right. So and then we usually like to see kind of, again, how we're doing. We've passed the 6,000 line mark. And again, remember, that's just code. That's not counting the comments. There's another 2,000 lines of comments. But having said that, we've got slicing working for strings, and it's Unicode aware, which is really nice. And we've got our index is working with negatives. We added some caching to our objects, to our string objects, and we were able to still maintain the ICU being hidden behind our UnicodeString class. So that was a lot of good work, I think, for this episode. Once again, hey, thanks for joining me, and Yeah, I'm hoping it's worth it for you. Thanks. Have a great day.